All right, good morning, everyone. Of course, when the topic of discussing multi-stage maintenance came up, I was excited to have the opportunity to present some information to you. It was a little bit of my goal to pass along information and things that we generally share with customers when we visit with them and things of that nature. So from a maintenance standpoint, a lot of times we see hatcheries that oftentimes are, maybe in a situation with maintenance where they're not really comfortable in getting a program started or not necessarily comfortable with exactly what to look at. So I'm kind of taking this as an approach from multiple points. One being, let's identify the things that we feel like are important when it comes to maintenance. But also the idea of how to get started with a good program. So, and identify some of the things that we see on a regular basis when we go to visit with hatcheries. So to begin with, we will review what I use as a semi-annual maintenance checklist. I've designed this one specifically for classic multi-stage incubator. And so we'll go through that in detail. We're going to also discuss the heart of the machine, which is the internal overhead recirculation fans, and as far as maintenance and making sure that those function properly. The function of the duct, if you are in a situation where you have some older machines and you still utilize the duct system, we want to make sure we cover that. Turning, which is very critical, and then also calibration. So hopefully we'll answer a lot of questions in regards to these specific topics. And so to begin with, let's review what we use today as and what I refer to as a semi-annual maintenance checklist. Now, this is a checklist that we developed inside of the Chickmaster organization, specific to the classic incubator. And we kind of look at it from this perspective. It's designed to keep your machines operating at peak performance. And then also look at it from a standpoint that a little preventive maintenance on a routine basis helps avoid a lot of reactive maintenance. And so I think we probably all have a pretty good understanding of the difference between preventive and reactive. And unfortunately, in older facilities today, we see a much higher percentage of reactive maintenance versus preventive. And the more reactive you become, the less time you have to do preventive. And so a goal with a good maintenance program is to try to reverse that, spend more time doing preventive and therefore have less reactive. And so when we look at the details associated around this specific check sheet, what we do is we try to take this sheet, and of course it's an Excel spreadsheet. And if you'd like to have a copy of that, you can definitely request that, and we'll make sure we send that to you independently. But this check sheet, as you can see in the beginning, and this is just the top portion of it, but I have it set up where you have the ability to have, this is 4 incubators on this sheet. You can actually have room, you may want to add a 5th incubator on there, but that way you can do multiple incubators on one individual sheet. You don't have to have a sheet on a per machine basis, but you can most certainly modify the sheet to fit your application and do it however you would like. So to begin with, we do break the incubator down on a per zone basis. So you do have a zone 1, zone 2, and we begin simply by focusing on, the heart of the machine, the fans. When we look at this checklist, what I'm really trying to accomplish here when I look at fans is I want to look at the condition, the position, and the sanitation of each one of these fans, all 6 of them or if you've got a machine that's smaller and just has 4. But either way, the goal is to check these items. And I simply want to look at the 3 in zone 1 and put a check here that I've checked a condition, position, sanitation, do the same thing for zone 2. And I'm going to go into a little bit more detail around these items associated with the fan, simply because of my statement earlier in saying that it's the heart of the machine. As we go down the list, oftentimes we see issues around fan bolts, that hold not only the motor mount bracket into place on a wooden fan board, but the bolts on a Vosterman kit as well, and even the fan guard itself. Oftentimes we see those those wear down. So it's good to have that on your checklist. Obviously looking at board gaskets, duct sanitation, cooling coil sanitation. And again, with cooling coils, if you have a Millennium machine where you have split cooling, the coil, you have basically 4 coils in that machine, 2 in the front, zone 1, and 2 in the rear. And those coils have fins on them, and they do have a tendency to collect a lot of debris on the coil itself. And so it's important to semi-annually check these coils and make sure they don't have a lot of debris buildup on those. And so that becomes important, even if it's a non-Millennium. If it does have the older, larger copper cooling coils, those can have a tendency to get a lot of buildup on them as well. So it's important to have that on your checklist. Also look for any leaks in the cooling system, such as where the tubing connections are, where it connects to the end of the coils. And then also I've got noted here a cooling filter. And what this is in reference to is actually the strainer that's on the chilled water supply service coming to your machine. Oftentimes this gets overlooked in some situations. It's something that hadn't been checked in several years, and you pull that filter out of there or that strainer out of there, and you see a lot of debris build up, which really just reduces your cooling capacity to the machine. And then of course, I've got heating amperage, and I put that on there because I think it's important, regardless of the age of your machines, to semi-annually force the heating to function and then take an amperage reading of those heating elements. And that way you have that documented. And so when you look at that from a zonal standpoint, you've got, on a ducted machine, you only have 2 heating elements. You've got one for the zone 1 and one for zone 2. On a Millennium machine, you've got 6 heating elements, but the 3 in the front function together, and they're all tied to the same service. So it's important to semi-annually check the amperage on that. Anyway, and then also to give the heating elements, if it's in the duct, it's good to visually look at those heating elements. Again, they have periodically they get a lot of buildup and debris, things such as feathers and dust that come in on the egg pack will build up on those heating elements, making them not as effective as they should be. As we continue down our list, we look for humidity leaks, anything in the system that could cause water to either build up in the duct or to drip to the floor of the machine if you've got a cyclomist system in a Millennium machine. And then again, you've also got a filter or a strainer on your humidity system, and it's important to make sure that gets checked and cleaned periodically to make sure we're not restricting our flow capacity. And then for the top portion of this, we finish up with looking at door gaskets and then also silicone joints. I think everybody probably understands the door gasket review or comment and the reason it needs to be checked, but we oftentimes overlook silicone joints. And what my reference to that is the way the machine is physically put together. It's constructed of fiberglass reinforced panels, or FRP, and they're joined together generally with an aluminum extruded material, and then it's riveted, and then those joints are siliconed. And what can unfortunately happen over time is the silicone can get washed out or pressure washed out of that seam, and then you create an opportunity to allow moisture and bacteria to get down into that joint. And then you have a bacteria source that's almost impossible to ever get cleaned out. So it is critical to check that periodically. The second half of the sheet, or the lower portion of the sheet, I begin with turning, and we want to focus on making sure that we actually document the left side angle when it's turned forward and then rear, and same thing with the right side for forward and rear. And we'll get into how to set that and what to look for with getting this set properly a little bit later in the presentation. Also do a visual inspection of hanger bars. I've got a slide where we'll discuss that and what you actually want to look for there. And then obviously chain tension. So once we get past the check portion of the list, we get into, from a maintenance perspective, a point of where you need to actually lubricate things. So turning pivots, such as rivets on the end of tray frames and hanger bars, and on the end of the cam system where it connects to hanger bars. It's important that all those things actually get lubricated. A lot of hatcheries never really take it to that level of doing any type of lubrication there. And so oftentimes you see extended wear or damage that comes as a byproduct of that. We generally, when it comes to lubricating pivot points or the turning chain, for instance, we normally recommend some type of a white lithium type of grease to use for that. I've seen some hatcheries that had basically had a can of WD-40. And keep in mind that a lot of certain types of lubricants, while it's a short-term lubricant, things such as WD-40 are really meant to basically keep something from getting seized or eat away rust. And so a lot of times when you apply WD-40, it actually eats the grease away, and it can create bigger problems later. So it's important to make sure you actually use a lubricant and not something that's going to wash the lubricant out. Turning bearings, which that is your 4-bolt flange bearing that's on your turning bar that bolts directly to your main beam, that has a grease fitting on it. It's important to use a heavy duty bearing grease and to grease that periodically. And so that's something that obviously a lot of hatcheries, I think, overlook, is lubrication. So once we get past that, what we try to focus on a little bit is physically force or operate the functionality of the machine, such as the heating, cooling, humidity, turning, and then a damper, or if it also has a blower, to actually force that blower to to operate and make sure that it does the right thing. So it's important to process through those things, because a lot of times you'll see one of those functions that's not operating correctly, and it's a good time to make sure you just double check all those things semi-annually. Once you've processed through these things, we also recommend calibration, and that's of a temperature probe, which is your dry bulb, and then a wet bulb, or if you have a relative humidity sensor on a Millennium machine, it's important to calibrate those on a regular basis. So we will get into a little bit more detail around the calibration a little bit later in the presentation as well. So the thing to the take home when we look at the details around a checklist is, what I always try to tell people is, it's important to create your checklist. You can use the one we have, but you can simply modify it to fit your needs a little bit better. But a lot of the things that I try to focus on a little bit in teaching a hatchery how to get into a maintenance program is, when we go through these checklists, it's kind of critical in a way where you do document certain things, but you also check those off. And if you find an issue with something, let's just say, for instance, that we've performed this checklist on our first machine and we find that we have some issues with the condition of the fan blades. Well, what we want to do is we want to focus on the process of getting that documented. Because what's important is, if we don't continue on to the next machine and do documentation and all of these checks, then we'll get hung up at the first machine trying to fix all of these little issues. And so the reality of it is, develop your sheet, process through all of your machines, get things documented, pick out items that are similar or your biggest issue. And let's just take fan condition, for instance. If you find that consistently in a majority of your machines, then it becomes a work order. You create a work order, and someone in maintenance will process through going through each one of those machines and correcting those issues. And therefore they minimize the number of tools they have to use to do that. it allows them to quickly process through every machine just to fix that one issue. And therefore, they're not going to a machine with every tool that they have and spending multiple days trying to fix everything around that one machine. Because when you do that, if you've got 56 machines in a hatchery, it may take you 6 months before you get to the last machine. In the meantime, you should have backed up and processed through the individual items one at a time. So kind of minimizes work efforts in the machine as well. So to take it a little bit farther, we're going to look into some more details. First, what's the most important item in the incubator? We talk about the internal overhead recirculation fans. And the things we focus on there is sanitation, condition, and position. And the thing that we're trying to accomplish with these fans is, if everything is in great shape, it's all about creating high static pressure. So this pressure that's created as the fan operates is what pulls fresh air into the incubator and allows proper internal recirculation for consistent temperatures. And so that's what we have to keep in mind. Unfortunately, the fan is what comes in contact with the air being pulled in and the recirculation. So it has an opportunity to also get damaged or to get dirty or to be not in the proper position. So let's work through a few of those details. When we look at the cutaway of the overhead fan section, and this particular image is of one with wooden fan boards, also shows, the duct. And we look at a cross section of this, we can recognize that the fresh air intake duct or inlet duct, this runs from the front of the machine all the way to the rear. And above each one of the fans, there's an opening in this duct. And with this fan in proper operation, what you'll find is above the fan then is a severe negative situation. It creates a suction. So it's a very negative draw, and that's what allows this machine to ventilate. It's basically known as a self-ventilating machine at that point. It doesn't take a lot of pressure differential to get airflow to go through the machine. So if the fan is in really good operating condition, the volume of air that it pulls in is going to be higher than if we have an issue with this fan. And so that's what's important to keep in mind when you think about how critical it is to make sure that these fans are in good shape. We look at some examples of that. The picture here on the left, you can see a lot of dirt and debris build up on this fan blade. Oftentimes, and we've done many different trials and procedures where we've taken an older machine that was in very dirty or poor condition and measured air velocity, measured static pressures, and then went in and simply cleaned it and made it look like our image here on the right. And we've documented anywhere from 10 to 20% increases in static pressure and air exchange rate through the machine. So don't look at this and think, well, my hatch looks okay right now and I'm happy with it. You can't give this enough attention to make sure that everything is clean and in good operating condition. You get a little bit of a closer look at this, you can see the fact that this is the cutting edge of your blade. And as the fan rotates, this essentially cuts into the air and forces it down through the fan guard. And so when you have this volume of dirt buildup here, that fan's not going to do that very efficiently, not going to create very good static. This is another image of where you see a lot of the dirt, this debris that's built up here on this motor. And this particular situation was in a hatchery that was fogging in the incubator room, which I have no issues with the fogging. It's just you want to make sure you follow proper procedure. Ideally when you fog, you're trying to apply a disinfect that's going to attach itself to a surface and therefore, kill anything on surface contact. And so the rule with fogging is to fog long enough to create a fog in the room, and then basically you're done. You've done all the work you can do. If you let it continue to run for another 15 or 20 minutes, then that fog has a tendency to really carry over into the duct on the machine, and not only do your blowers and your fresh air intake ducts or your dampers or the internal duct, but this carries through and physically attaches itself to the motor, because that's the first thing that fresh air hits as it comes in. And now you've got a sticky residue that starts to collect dirt and dust and debris. So if you see this situation in your hatchery, a lot of times this is a byproduct of just excessive fogging. So you may want to look at your procedures for that as an attempt to help get everything cleaned up and keep it from being a continuing issue long term. Another situation we see a lot of times with fan is here you can see where the tip of this blade has been damaged. Anytime that you have damage to a blade, it will affect its ability to create static and move air properly. So what we focus on with position is, when you look at these two illustrations, the one on the right, as we look, we really want this motor to be centered in the opening. So we have the same spacing from the fan board down to the edge of the blade on both sides. And then the goal is to get the bottom of that fan blade basically equal to or even with the bottom of the fan board. And that creates a spacing here that allows this blade, as it rotates, to build static and force the air down and not allow it to bleed out off of the tip of the blade. So when you look at these dimensions, what you're physically looking for is a distance of anywhere from 1/8 to 1/4 of an inch from the tip of the blade down to the fan guard. So it's important to get that spacing correct. This is a big key issue. I was in a hatchery fairly recent that had gone through and put in all new fan blades, which was great. It was a great step on their part. Unfortunately, they didn't recognize where this needed to be, and the majority of them, the blade was way up out of that opening. So they had lost a lot of static. And the way the story goes is, hey, we put in all brand new blades and we lost 1% in hatch. Well, they didn't put the blades in correctly. So this is important to share with your maintenance staff and make sure they understand where that blade positioning needs to go. When you drop a fan board on a wooden fan board machine, this is what you'll see if you've got a blade that's not down in the opening. So as you can imagine, as this blade rotates, air is off the tip of this blade is not forced down, creating good airflow. It actually allows the air to bleed off of the edge of this blade. So with fans being the heart of the machine, one of the things I always try to focus on when I go to a hatchery is we recognize that hatchery managers oftentimes today don't necessarily have time to go into every machine and check every fan board and look for these types of issues. Obviously, you have maintenance should be processing through a checklist. But at the same time, if you do catch yourself in an incubator, what's so easy to do is to step into the door and walk from the front of the machine to the rear and back to the front. And what you're basically doing is you're trying to feel airflow off of the fans. And if you do have a fan blade that is damaged or is excessively dirty or is not down in that opening, you will find that one fan that is not moving very much air. That's going to create an odd zone in that machine. It'll oftentimes create overheating or just simply inconsistent temperatures. And as a byproduct of that, it's so easy to pick up on those fans that are completely out of sync simply by feeling for the air. When we look at the Bosterman fan, we get into a lot of the same type of situation from a standpoint of dirt and debris or damaged blades because they're a plastic blade. So it's important to inspect them and look for all those same types of things. Even though you do have a fixed motor mount, you have to watch for making sure these bolts are tight and don't work their way loose. And again, the sanitation and condition of the blade is what's very critical with the Bosterman fans, to make sure these fan guards stay clean, because it will reduce that airflow greatly. So additional characteristics of blades that are in poor damaged condition, you see old blades a lot of times that are very, very old, and because they've physically operated under such a high static for so long, they'll actually try to flatten out a little bit or lose proper angle. So it's important to update those periodically. A blade can be warped. Oftentimes it's just poor handling before installation. See that quite often. A lot of times if I drop a fan board as the blade is because the power's cut off to it, as it slows down, you can kind of stand off to the side of it. If you've got a warped blade, you can visually see it at that time. Tip of the blade can be bent. A lot of times we see things that fall into the blade and therefore damages it or bends it. Incorrect blade, maybe from a hatcher. Oftentimes I see that because we have such a challenge in a hatchery today when it comes to training and with maintenance, and oftentimes we don't necessarily have maintenance personnel that have been in the hatchery for a long period of time, and a lot of times they see a blade that gets damaged or someone says that needs to be changed, and they basically go to the shop and just grab a blade. Let's just, it's important to make sure you got the right one. So all of these issues cause reductions in air movement, and then a lot of times we see these cause excessive vibration. You can step into an incubator hallway a lot of times and you can hear a machine that's vibrating pretty bad, and generally caused by the fan. And unfortunately with older machines, this can cause mercury stats to split. It can also cause excessive motor bearings, to fail in motors. So it's critical to keep on top of making sure all of those are in good shape, because again, you're preventing the issues that create a bigger problem, such as bearing damage. So when we go back and look at this illustration, and this is for hatcheries, obviously, that still have a duct, but the important thing to realize here is that the duct itself, the inlet, is down here below the fan board. Air enters the duct here. If you look behind this door, that's where your heating element is and your humidity tip. And then as you look further down the duct, you see what we refer to, this louvered section is actually referred to as a water eliminator. And it's designed to allow water from the humidity spray to hit the louver and therefore evaporate prior to hitting the fan. As we know, water evaporates in a pure state. So any hardness or anything that's in that water will just stick to the motor. But with good fan condition and good static and good negative suction draw here, this allows these three fans to work together to pull air through this duct that is fed from the other end of the machine. And the duct on the other side works in reverse. So again, the condition of the fans and the condition of your duct is very critical in allowing a machine to heat properly, humidify properly, and then exchange air from the front to the rear of the machine, so you avoid creating big temperature differences from front to rear. So when we look at that as an example, obviously here on the right you see a newer duct or a newer water eliminator, and with it being clean and in good condition, it's not going to cause any airflow restrictions, as opposed to this one that's here on the left in this illustration. Something that's overlooked quite a bit. Again, this is a lot of hardness buildup over the years and dirt and debris, and it simply keeps your machine from exchanging air from front to the rear, and it doesn't allow it to heat properly following egg sets or say following transfer. So this is a very, very critical. Make sure this gets accomplished. And again, this is one of these items that's on your checklist, and you're going to look at the duct and you're going to go, oh man, that needs to be cleaned. Well, don't stop your checklist just to clean it then, but if it becomes a repetitive situation you see in all the machines, that becomes a work order you've got to create and a task that you have to go back and get these things removed and cleaned up or put new ones in. Also, a lot of times with these older machines that still have the fan boards, or even with new boards, they still have a duct situation, and a lot of times we see old, worn, or as you can see here, missing gaskets. This allows the air from the positive side of the machine to escape around the duct and actually just pull into the negative side of the fan as a bypass. And so in this situation, you don't get good airflow through the duct again, and you obviously won't heat up as well as you should, and humidity don't work as well. So these gaskets are important to review semi-annually to make sure they're in good shape. So let's talk a little bit about turn angle. And this illustration, I kind of like this. It's been around for a lot of years. A lot of people have seen this. You know, if you take a piece of paper and you fold it over toward the edges meet, you have a 45-degree angle. You know, basically the design of the machine technically doesn't allow a perfect 45-degree turn angle in both directions. Under normal circumstances, in a good condition, you're going to achieve a 40 or a 41-degree turn angle in both directions. But the things that's important to understand is that with proper turn angle, you also have controlling this distance between these hanger bars. So this distance here allows air from the fans that hits the floor and is pulled back up through this opening. And as it pulls through this opening, it allows air to cross these flats of eggs. And so if this distance is too narrow, then you don't have proper recirculation. If it's too wide, you actually don't build up enough resistance and the air has a tendency to short cycle. So getting your turn angle set is critical, not only from a standpoint of allowing proper embryonic development. It has a lot to do with airflow through the machine and how it is introduced to the egg pack. So when we look at turn angle, one of the first things we always focus on is recognizing that in order to get consistent turn angle from one side to the other and front to back, the first step is getting the crank arm where it aligns perfectly with the pitman bar, and set that limit switch that's on your turning bar where that's its stopping points. So here's one stopping point that's to the rear position. It's still perfectly aligned. And then in the turn forward position, you have this alignment. So that's the first step. That doesn't have anything to do with turn angle. That has everything to do with consistency of where this crank arm is supposed to stop. Our next step then is here with the power cam. We have to adjust the nuts here on the all thread in order to adjust our turn angle. So our goal is to make sure that the rivet on our power cam is the same distance from the beam, whether it's turned in the forward position or if it's turned in the rear position. And this is what gives you consistent turn angles from front to rear. But again, the very first step is to make sure that you have your crank arm and your pitman bar alignment are controlled where that limit switch stops them at. So this is always your first step when it comes to getting your turn angles consistent from forward to back. So additional items that affect turn angle, we look at chain tension on the sprockets. We also look at damaged or worn out bearings on the turning bar, worn slots on hanger bars, both front and rear, and then you'll see worn rivets on tray frames, front and rear. Of course, if not maintained on a regular basis, these items can cause extended downtime. You know, we know that you'll have a rivet that fails, or you'll have a hanger bar that breaks, and now you've got a situation where you've had a lot of damage to your egg pack, and it takes a little while to fix this problem. It's not something that you can just go fix in 10 minutes. So by maintaining, lubricating those joints and getting the position set correctly, you avoid the major downtime. We look at those hanger bars, you know, on the left, this is a new hanger bar, and you look at the distance that you have from here to the top. This is an old or worn hanger bar. And obviously this one has almost worn plumb through the end of this. And, you know, that just is an extended years of operation where you have a metal to metal contact on this rivet. And again, eventually this is going to break at this end point, and that whole tray, that whole column of eggs will just drop and creates a huge damage whenever it tries to turn the other direction. So it's critical to review these on your semi-annual basis. It's a whole lot simpler to schedule a time to change a hanger bar than it is to try to fix one that's already broken. With this type of wear, what you'll commonly see as well if you look at the side view of the rivet on your turn cam, is you'll see a lot of wear right here through that rivet. Obviously, if you put a new hanger bar on this, you've only corrected the situation with a hanger bar, but you're probably still going to be in a situation short term where this rivet will eventually break off. And again, you have the same, downtime in regards to trying to fix that. So very critical to keep these joints lubricated and to check that semi-annually on your list to make sure those are in good shape. So the next thing that we discuss quite a bit when it comes to maintenance on a machine is calibration. You can obviously today we have equipment such as our RC2 kit. Also, we have the older Chickmaster mercury calibration thermometer used to check calibration. And then, of course, we have the suitcase style, which, had the digital readouts on those. And the thing is, to me, the most important thing when it comes to this type of equipment is to just make sure that it's in very good operating condition. So we try to focus on getting hatcheries to calibrate at least once every 6 months. So it would be on your semi-annual list. And then again, if anything happens, such as if I have to change out a temperature probe, or if there's a wiring issue in the control panel where I have to do some changes, or my PLC input card maybe has failed or anything like that, any of these type changes tells me that I probably need to calibrate that machine again, because that will change the voltage that's going to that probe and therefore give you an inconsistent feedback to the PLC to tell it what the actual temperatures are. So, and then again, any issue with hatchability or production quality or timing, such as chick readiness, things of that nature, any kind of an indicator there would also be a time to go back and plan a calibration. So, we also see where we have inconsistent calibration. If you are lucky enough to have Maestro, where you can look at front zone and rear zone cooling, front zone and rear zone heating. If you recognize huge differences such as this over this time period of a day, 24 hours, we saw that the front cooling worked 12% of the time and the rear cooling didn't work, but just there's one little spot right there. So this tells us that this machine is using a lot of front cooling and no rear cooling. And then when we look at the heating, this is a recovery time that occurred as a byproduct here of warm-up time following an egg set. And you can see where it took an extended period of time for the front to get up to temperature. And it may be just because they left the front door open longer. But this is enough information through your system to tell you that it's probably a good thing to go check and make sure that your calibration is correct. So best practices when we look at calibration, my first rule in calibration is to calibrate your calibrator. And so that's taking a lot of times, my reference to that is to use a gallon jug of water that you put in a machine, bring it up to temperature over a period of time, and essentially use your Chickmaster calibration thermometer to verify the temperature, and then to put the probes from your calibration device, regardless of whether you're using an RC2 kit or an older suitcase style of calibration kit. You just drop those down into the water. And the main thing that water does for you is, because it's a volume of water, it doesn't change temperature very fast. And so this allows you to verify with your calibration device that all of your probes are reading the same exact temperature. So that's the number one rule in calibration: calibrate your calibrator. So the next step, again, in multi-stage setters, we always talk about calibration should occur after transfer and prior to egg set. The key there is to just make sure that you have a machine that's in a very stable state and hasn't been heating a bunch or cooling a bunch, and therefore you have more consistency in temperature. So what's important is make sure you leave the probes inside the machine until they're stable, alter calibration values to match the monitor, and then continue to monitor it for another 10 or 15 minutes to to just make sure that everything is reading consistently. Whether you have a Gen 4 or you have a, an older Gen 3 type system, calibration is pretty simple. But the key there is calibrate your calibrator, make sure that you are in a current state with your machine where you have a stable environment, and make sure the probes are left in the machine long enough to stabilize. So in wrapping things up, we talk about keys to good maintenance. And in a lot of situations, we want to make sure that you have properly trained maintenance personnel. Take your check sheet, make sure you understand every step of it and how to perform that. In addition to that, you want to make sure they're detailed check sheets that fit your application. In addition, proper tools and adequate material to finish the work. There's nothing more frustrating than try to go perform a maintenance check and you don't have the right tools you need or material to process through that. And then the discipline to develop and follow a schedule to completion. I think probably one of the most underutilized pieces around our Maestro system is the fact that it does have a maintenance scheduling function with it. And I think it's underutilized in most cases, but to simply put, a lot of hatcheries managers will use their Outlook calendar and to develop schedules inside of that. So it's basically just a reminder or create tasks to remind them of when work needs to be accomplished or when the checks need to be done on the machines. And with that, I think I'm wrapped up. So.
Thank you, Chad. No problem getting my microphone to work again, but here we are. Yeah, thank you for all the information. A lot of good detailed information in there that I know for those that managing chick master hatcheries, you got very well into the specifics of what should be done and whatnot. One of the questions that all hatchery managers are always struggling for time and such. How much time should be expected for somebody to go do a good thorough check of their setters and hatcher machines? Actually, you can unshare your screen now as well.
Okay. Yeah, so if your check sheet is extensive as this one is, which this is referred to as a semi-annual, this is in reality going to take about 30 minutes a machine to go through this. Bear in mind, the focus is to document and not necessarily correct issues. You come back and create another work order to correct the issues, and therefore you can process through, doing your checks and lubrication and things of that nature. You can do all of that pretty quick. So 30 minutes a machine.
And that can all be done at any time when the machines are running, or, do you have a recommendation on that?
A lot of hatcheries have found themselves, ones that I've worked with quite a bit over the years, have found more success with training a night maintenance person or a weekend maintenance person. So they don't have they don't get the phone call in the middle of the day saying, hey, the separator's down, or the tray wash isn't working, or the vacuum pump's broke, or the chick counter's,
yeah,
putting 110 in every box. So at the end of the day, they've found that people that work either night shifts or weekend shifts, avoiding processing functionality, it's allowed them to quickly process through and doing their maintenance checks without being interrupted. So I think that's a good goal.
And sometimes they, like you said, they wouldn't necessarily be fixing it then. They could do it on the off hours or whatever and identifying what's there.
That's exactly right.
So you wouldn't have to have the necessarily fully competent person to do that by themselves at night or weekends, unless it's of course, if it's an emergency, something's going to be fixed now. It's going to affect something right now.
And that's what we're trying to avoid, right?
Right. Yeah. Preventative maintenance. Yeah. We're trying to avoid the fires that come out. It's like, oh my gosh, we got to do something, which many hatcheries, yeah, even with the preventive maintenance, you're going to have some of those pop up, but yeah, we're trying to avoid those.
Oh, of course.
In your areas of working and visiting hatcheries and stuff, what are a couple of the major areas of neglect that you see in hatcheries, that problems they have that really, if they had been doing their proper preventive maintenance, they could have avoided?
Well, it probably boils down to a couple of things. One, the condition of the fans. Those have a tendency to be probably 8 out of 10 facilities I'll visit will have situations with those fans, either blades that are really old, have a lot of dirt and debris, not in the correct position. It doesn't create enough static, and therefore their temperatures are kind of a little bit all over the board. So the fans are one of them. And then turning becomes an issue. A lot of times in these older machines, you know, the physical aspect of the turning motor, getting that cam switch set correctly where the stop is in the right position, all of that can be a challenge with older equipment because it's physically worn and hasn't been maintained. And so it's a bigger challenge to get those type of things correct. But at the end of the day, it is majority of the time you see issues around fans, and then you see issues around turning.
Mm-hmm. And what would be some of the signs of that? Like if you're just going and pulling your regular hatch, and you know, what might you see if all of a sudden, hey, we've got some fans that are really out of whack or whatever? What would be some signs you might see?
So with the fan situation, a lot of times, especially when you get into this time of the year, seasonally, if it is summer where you're physically located at, you see higher temperatures in rooms, you see higher humidity, and a lot of times you have more struggle with achieving adequate moisture loss in the incubators. And one big step in curing moisture loss is air exchange. And if the fans are in poor condition, you have really bad air exchange rate, or it's not adequate, and it reflects itself in moisture loss. So you start seeing, you know, chicks that are showing signs of lack of moisture, bigger bellied chicks, you know, red hawks, a spread in hatch, you know, because with the fan situation, you have inconsistent temperatures, and chicks out of the front of the machine may pip out several hours in advance of chicks that come out of the rear of the machine. Right. So when you see a spread and hatch and you see the chick quality start to go downhill, it is a seasonal effect, but a lot of that is driven by just the poor condition of the fans.
And that kind of goes back to what, you know, we talk about a lot, is knowing what's normal and then keeping records of it. Because if you start seeing something, it's like, why is this happening? Well, you know what? It started happening the same time last year. You know, then it's like, okay, so now it's a seasonal thing. What did we do last year, and what did we do to correct that?
Sure.
One question is that where the hanger bar sits on the cam pin, part of your turning, is it necessary to put any grease there on it, or let them free run? Or
yeah, because that's a metal to metal contact, and you know, the rivet that's on the turn cam itself is built into that turn cam, and everyone that's ever had to change one of those knows that that's not an easy task. And so anytime you have a metal to metal contact, you're physically going to have deterioration of the metal, and the weaker metal, which is actually from the hanger bar, is going to wear quicker than the rivet material on the cam. So what is important is to try to use some form of like a white lithium lubricant, and if you'll do that, you'll have you'll extend the life of the hanger bar and that rivet for many years. It won't wear near as fast.
So it is recommended to.
Yeah, definitely.
What's the latest upgrade that you would recommend for the Chickmaster multi-stage machines?
Well, I think, you know, when we look back at a lot of the upgrades that Chickmaster's provided over the years, you know, to me, the one that stands out the most, that in hatcheries that are in really good operating condition, even hatcheries that are in bad operating condition, still see a big improvement when it comes to implementing a split cooling system. You know, because they trying to get, you know, air as it enters the machine. Ideally, you want that to be evenly distributed throughout the machine, and that can be difficult at times. And so you'll see a machine that when it's turned forward runs very consistently, but yet when it turns to the rear, all of a sudden you see, you know, some weird things going on with heating or cooling function in the machine. And anytime you can split that heating function and the cooling function to allow it to work independently, you're making big improvements, not only in the temperature control in the machine itself, but in energy utilization. So the way the older machines, if I don't have split cooling, if the machine calls for cooling, you know, it's just one solenoid in one system. You basically end up trying to cool the whole machine. Yet you don't need the cooling in the front, then you see the front heat cycle the second that the cooling is done. And so now you are wasting energy to reheat a space that didn't need the cooling to begin with. And then you're also wasting cooling energy because, you know, it's more load on the chiller. So at the end of the day, temperature consistency is so much better, and you improve your energy situation. So,
and that's one of the things that really helps our hatch window is getting that uniform environment. And you're actually managing that environment, you know, in
well, and one of the things, you know,
yeah.
Well, and I didn't cover it here, you know, because of time. I mean, literally, you could discuss this topic for hours, but the reality of it is, you know, if I see chick readiness, which one of the things, if I've ever been to your hatchery and you've seen me, one of the things I talk a lot about is going to a hatcher and looking at it 18 and 14 and 16 hours prior to pull and looking at chick readiness, you know, because generally everything that comes out of the front is in the two stacks, either to the left or to the right. And then you've got, you know, and vice versa. So if you've got a big difference in temperature from the front to the rear, you're going to see that in chick readiness. That's just your number one indicator to say you have an issue with that individual machine. And let's face it, in these bigger hatcheries today, where, you know, you're doing a weekly egg set of 1.6 million, you're processing a lot of chicks in a day's time. And you may be giving up some hatchability on individual flocks due to specific incubators, but it's so hard to identify in such a vast detail associated around the volume of chicks that you hatch in a given day. And those chicks end up in a certain house, and all of a sudden you have a 2-house farm where one house has, you know, high 7-day, and you know, by day 3 they've had a lot of mortality, and the other house looks great. Well, it's not a grower issue; it's where the chicks came from, you know, and it's so hard to track back today. So that's one of the first things. Of course, we try to focus on saying, hey, go in your machine 4 hours after egg set, do internal egg temps, top, middle, bottom, front, middle, rear, and look for variations in temperature, because if I have an issue with fans, if I have an issue with calibration, I'm going to see a big variation in those temperatures. And then, of course, monitor eggshell surface temperatures prior to transfer, and it'll point out those things as well.
Yeah. What would be your standard 18-day shell temperature, like, you know, about transfer time? And then also similarly is what's a normal incubation time for the Chickmaster multi-stage? So kind of two parts. At transfer, what should the shell temperature be? And also what's total incubation time normal?
Well, and I think the first thing to address there is we talk about total incubation time. You know, in the world of single stage, we really focused on saying incubation really doesn't start until the internal egg temp gets to a certain point, where with previous to that, everything in the industry, especially in the US market, was primarily multi-stage up until the late 90s. And so as a byproduct of that, we would calculate total incubation from the time we put the eggs in the machine, which you've got 3 or 4 hours of warm-up time that you've got to figure with that. And then in fairness, let's look at the breeds that we deal with today.
Right.
You know, if you're talking about a Cobb 500 or a 700 or a Ross 308 or a 708, you know, there's a vast difference. And so what I try to tell people most times is try to say, hey, listen, you know your breeds. You do have your primary breeder representatives out there that you can discuss with them. Hey, I've got a Ross 708. What should be my total incubation time on a young, prime, or old? And it varies. Same thing with the Cobb 500. And they're the experts of that breed to talk about that. But, you know, we see variations in total incubation time anywhere from 500 hours all the way up to 512 hours. And with multi-stage, the key to it is knowing how long it takes for your egg mass to get up to temperature. And from that point forward is where you calculate your total incubation time. And that, you know, within itself, then when you look at eggshell surface temps prior to transfer, you know, we know that we don't want our eggshell surface temps to be really much below 100 degrees. if you're seeing shell temps at 99.7 or 99.6 or 99.8 consistently, it may be a little on the cool side. But we also know that we don't want to see those eggshell surface temps exceed, 101.6, 101.7, because then you get into situations where, regardless of breed, it could cause some heat stresses. So you've got a range. Focus on the fact that you've got to deal with your primary breeder representative to make sure that you're inside of that range, and make adjustments based on that.
Yeah, and so if you're looking at your shell temperature, like you said, if you've got an 18-day-old embryo that's exothermic, it's producing more heat than it needs. So we're trying to get rid of heat. So if your shell temperature, like you said, is up at 100, 101, 102, something like that, that embryo is hotter than that. Because we're trying to get heat out of there. And so from that standpoint, that's why we really want to monitor that, because it's not saying that's not the temperature the embryo's at. That's the temperature of the shell, and the embryo is going to be warmer at that stage. So yeah, it is important. So kind of a follow-up to that, and kind of some of the things that you discussed here. One of the attendees here has low eggshell temperatures, less percent hatch in zone 3 and 4 compared to 1 and 2. Zone 3 and 4 always pull out 2 to 3 hours later than 1 and 2. What would be your comments? You kind of alluded to it, mentioned some possibilities, but what are your comments to that? So zone 1 and 2 are coming off quicker than 3 and 4.
Yeah, so that with having that many zones, that may be in reference to a customer that has a single stage machine as opposed to a multi, because in multi, the most zones that we'll have would be a 2-zone machine in multi. But yes, in reference to, if I've got a 4-zone, more than likely it is single stage. Mm-hmm. But anytime I see a big variation from one zone to the next in eggshell surface temp, there's something that's driving that. In multi-stage, what can oftentimes happen is we're allowing too much fresh air to dump into the front zone, and therefore the machine is not having to use as much chilled water to absorb embryonic heat out of that zone because of the volume of fresh air that we're putting in there. And yet in the rear of the machine, because of the lack of fresh air, it's having to use a lot of chilled water. Well, if I don't have split cooling, that cooling demand out of the rear is also driving a heat demand in the front. And at the end of the day, I may end up with a 0.5 degree variation in eggshell surface temp from one zone to the next, just because of that imbalance in air distribution or fan condition, things of that nature. Again, it goes back to having that split cooling capability, where I have a lot more consistency in eggshell surface temp as a byproduct of it.
Yeah. And you talked about this. There's a couple questions on calibration and stuff. And I believe you said you like to calibrate, at least every 6 months. Somebody had asked what would be the best ways in calibrating. Some people are asking even after every transfer. I mean, do you know people that do that? Is that something that you would, it's not really a problem, but is it necessary?
So I will say that it depends on the type of control that you have, because some of the controls that have been developed and provided by Chickmaster over the years, unfortunately, some of them are a little more voltage sensitive than others. And so anytime you have a big voltage situation at your hatchery where your voltage varies greatly, we find facilities like that have to calibrate more often, or at least they feel more comfortable with calibrating more often. And in most cases, when I find hatcheries that have very poor calibration situations, a lot of times it's been driven by our procedure. It's not necessarily the fact that they're out of calibration, it's the fact that they just do a very poor job of calibrating. And so with calibration, the being patient, making sure you do it at the right time, keeping the machine from over functioning while you're calibrating, all those things drive to consistency. And so, yes, there are locations that have poor voltage, and that does create requirements to have to calibrate more often. But under normal circumstances, worst case, really they shouldn't have to calibrate more than once every 3 months.
Unless there's some other conditions.
That's right, unless there are some other conditions. when you look at semi-annual, the thing I always try to talk to people about a little bit is the fact that it depends on your geographical location, but you may see big seasonal effects. So we know that the atmospheric temperatures of a hatchery here in the U.S. in the summer versus the winter is greatly different. In your conditions in your room, the volume of air through the machine, the amount of humidity that's in your environment, things of that nature can cause that big difference. So I always try to focus on saying, hey, make sure you calibrate once you get into wintertime. And then your second time you calibrate is going to be once you get into summer operation. So if you focus on a July and a January, if you can do it 2 times a year and be in great shape, that's where you would want to focus on.
Yeah, that's a good recommendation to kind of make note of when you do it and hit the different seasons of the year. Some hatcheries probably more so than others. And you had mentioned that about the procedural thing, and that was interesting. And one of the other questions is like, can you kind of review again that proper procedure for calibrating the temperature and humidity? You kind of mentioned that they can be doing it wrong. So then that question kind of came back up, the procedural thing again.
Yeah. So one of the things that oftentimes I see with hatcheries when they go to calibrate, of course, in a multi-stage machine, a Chickmaster multi-stage, you have 2 temperature locations, one in the front, one in the rear. The one in the front is as you enter the door, it's on your left. The one in the rear is in the back on the right. And then you also have a wet bulb probe on the older machines. And so first thing to remember there is when I set my calibration device down in front of my machine, and I've got to get those probes in there, I want to get everything ready where I can open the door, enter the machine, close the door. And then I can lay the probes out on the floor, get the probe up and over through the egg pack, up over the top tray of eggs, and generally try to use a rubber band or some type of a clip to get that temperature probe from the calibration device right next to the bulb of the probe of the machine itself. And so you place the one in the front, the one in the rear, and then the wet bulb probe. Technically a wet bulb is really just a dry bulb probe, but we just put a wick on there, and what we're basically doing is measuring the temperature that is created by as the water evaporates off of that wick, and therefore it calculates as a wet bulb. But what's important is to calibrate that wet bulb as a dry bulb. You want to remove your wick. What I'll have a tendency to do is to pull the wick completely off the probe, take it out of the water bottle, and just lay it there on the ledge there beside the water bottle, so I don't have any evaporation of water occurring around that wet bulb probe, because again, I'm going to calibrate it as a dry bulb. Now, it's not going to read the same as your other 2 probes because of its physical location being right there above the front door of the machine. But I still have a calibration probe by it, and I've got to calibrate it as well. So the biggest thing is don't have the door open very long. Again, make sure it's after transfer, prior to egg set. The machine should be very stable. If you've got a machine that's using a lot of cooling in the front and you're trying to calibrate, or a lot of heating, as a byproduct, you'll get inconsistent temperatures. And don't be afraid for a very short period of time to physically just, while you're outside of the machine, then open the control panel and physically just turn the breaker off for those heating elements if it's heating a bunch, or turn off your power to your chilled water solenoid. So essentially what you're doing is you're just telling the machine, hey, you can sit here and try to do what you want to do, but you don't want the cooling to function. You don't want the heating to function. You want to create a very stable environment. And if you happen to put the probes in the machine and 15 minutes later you're fixing to calibrate it, all of a sudden the machine turns, well, you better walk away from it. Let it turn, let it go another 10 or 15 minutes before it stabilizes again, before you enter your calibration offset values. Because otherwise you can create some inconsistency because the machine just turned.
We talked a lot about the eggshell temperatures and kind of allude to different things, and we can kind of respond to that in different ways. But one of the attendees says they're seeing eggshell temperatures close to 103 in the top and about 100 in the bottom. What would be your thoughts of what first thing that they need to look at?
Well, a lot of times what happens with that, is the fact that they're not, they don't have adequate airflow. So if the airflow is not adequate off the fan, it's not creating high velocity, and that without high velocity, it short cycles. And so you get heat that rises to that top, and therefore you will see those bigger temperature differences just simply because of the fan situation.
Yeah.
Yeah. So more than likely it's a situation with needing to check the condition of the fans.
Yeah, fans, or you even mentioned, your spacing between your columns there, and all, basically your air. If you think of your air, it's going to travel the path of least resistance.
That's right.
And so your fans need to be pulling the proper amount through, but you need to make sure everything else is uniform in there. Otherwise, you're going to have channels of air going quicker than others.
Well, and let's face it, it is a vertical airflow pattern machine. So as a byproduct, you are going to have higher temperatures in the top than you will in the bottom naturally. But you shouldn't see that big of a variation in temperature. The natural fact that you do have that variation is why under normal circumstances at transfer, you try to focus on inverting the egg pack as you transfer. So what comes out of the top ends up in the bottom, and the bottom ends up in the top. And that helps even out some of that just simply because of the temperature difference in the hatcher as well. But anytime you see that big variation, you've got to start back with checking all of the basics: fan condition, position, sanitation, air distribution, and making sure your turn angles are consistent both ways. And that's your starting point to just make sure that everything is where it should be.
And that 103 could definitely be detrimental.
Oh, of course.
In there, and that's going to affect your hatch window as well when you have that big a difference. And that was one of the other questions. What is consider a normal hatch window from eggs incubated in a multi-stage?
So in a multi-stage, it's fairly common to see 1 or 2 or 3% of your chicks pipping out, fairly early, especially if you're doing
biology
day transfer. That's right. It's a biology thing. So it makes it even worse if we drive those eggshell surface temperatures too high in certain places in the machine. So, under normal circumstances, I always have a tendency to try to teach people to use their monitoring system and document that humidity curve, the wet bulb curve in my hatcher. And when I see that wet bulb may consistently be right at set point in a hatcher, which may be 82.5 or an 83 wet bulb setting, but it may consistently be at set point, and then at one point it's going to start an upward curve. And the beginning of that curve in multi-stage, it's fairly common to see that in a range of about 14 hours prior to where my peak humidity or that peak of that curve occurs. A really tight window, we may see that as low as 10 or 11 hours from the time it starts to peak. And then on the after effect, be in the same situation where your humidity is back down to close to the 83 wet bulb within 11 or 12 hours after the peak. In multi-stage, you can be as big as a 28-hour window where you're 14 before and 14 behind, especially in hatcheries that are in poor physical condition in the machines.
Yeah. What being a ventilation person you are, what's a standard procedure used for the air exhaust in the multi-stage setters?
As far as measuring air exhaust?
Of the procedure, yeah, I think the standard procedure, or how is it mostly done for the most multi-stage? I guess a majority of the Chickmaster multi-stage machines that we see in various markets today were designed and installed brand new, where they really just had either 2 rear exhaust ports or they had 2 rear top ports. In newer machines, the Millennium machine has exhaust ports from the front to the rear on each side of the machine. And so you have, but generally those exhaust ports are collected into a duct on top of the machine and still goes to a center point. So for me, a lot of times what I'll try to train people to do is on a bank or a row of machines, say you have 10 machines in a row and you do have an exhaust plenum, then you have that opportunity to be in an open plenum and use an anemometer and measure airflow exhaust out of each one of those openings.
And it helps you identify out of the 10, you're going to have one that has the most exhaust and you're going to have another one that has least. You know, and it's a good procedure periodically if you have a pressure control plenum and you have access to be able to measure that exhaust kind of equates to how good a shape are my fans, how much static am I building, how much airflow do I have going through the machine as a byproduct. Also, door gaskets and things of that nature come into effect as well. You know, so how much air am I leaking out of the machine versus going out the exhaust port? So anything on the bottom end is always going to be a reference to say, these are the machines that probably need the most focus when I look at internal airflow.
Okay. Somebody's got a situation where they said they're encountering their low temperature alarms at roughly the same time they're getting high temp alarms. I mean, how do they manipulate the ranges in their setup so they're not getting these? I imagine what's happening is you got low, and so then it's like, boom, we need to get heat. So we get heat, and then you also hit the top and have to come back down. Is that something you would manipulate in your settings for your alarms, or look what's causing this?
Yeah, it technically it could be a P depending on the type of control. You know, if it's a Gen 4 control where you can set your low and your high for your front and your rear zone, even though you can adjust those, the fact that it's occurring is an indicator that you've got a big variation in temperature from the front of the machine to the rear of the machine. You know, so in that particular situation, it could be a byproduct of humidification, how humidity is being applied into the machine. It could also be a byproduct of the lack of split cooling. You know, with the older system and no split cooling, where it's basically just one system, what can happen a lot of times is if your water flow is not regulated very well, when it does call for water, you get this large flush of cold water that comes into the machine. And if you're not putting, and I see this happen pretty often, we've regulated our air coming into the front zone. And so as a byproduct, we're putting too much air into the rear. And yet the front then is going to have to call for cooling. Well, when it calls for cooling, guess what? Now you're overcooling the rear of the machine, because the water can't get to the front without cooling the rear. And now you have a situation where, especially if you have a low water flow, you overcool the rear and you get that low temp alarm, but then you don't get enough water to the front to ever cure your cooling demand. And now you get a high temp alarm in the front. And oftentimes when that's happening, it's about air distribution, and then it's about water flow through the coil. And a lot of times in that situation, you unhook the return water off of those coils and put it into a bucket, and you force the machine to cool, and you're basically flushing sediment out of those coils. And I can't tell you how many times I've found hatcheries where we filled up we're into our fourth, fifth 5-gallon bucket before the water clears up. And it's just flushing sand and silt and debris out of those coils, which basically dampens flow rate. And so a lot of times that becomes the situation. The coils are the lowest point in the whole chilled water system. So any debris or silt or anything that's in that water, it settles in the coils and it never gets flushed out.
So addressing the cause of that is definitely the first thing you do, rather than just adjusting your alarm type of thing, right?
That's right. Yeah. It's still happening
one of those,
for a reason.
Yeah, it's one of those things like, let's just make it not send the alarm to us. Something's
sure. And that's common. Let's set our low temp a degree below and our high a degree above, and you'll never have an alarm.
Yeah, but that doesn't fix problems. But, well, thank you, Chad. There's a lot of good discussion in your presentation and also afterwards. A couple of questions that were asked that we'll address, have Chad address one-on-one in an email. They require a little bit more information, I think. So we'll have Chad address that later directly to you. But thank you again for Chad, for your time and effort. And also thank you all for participating. And we look forward to seeing you in our next webinar series. So have a good day, everybody.
Thank you, everyone. Have a good day.